conservation, science, and exploration into classrooms around the world. Now that the school year is in full swing, we can be broadcasting up to 30 to 50 live events per month. So definitely make sure you check in on our website to see if there's any others that you're interested in. So today we're super excited to have Dr. Abigail Fraeman joining us. She is a research scientist at NASA's Jet Propulsion Lab in Pasadena, California, and a deputy project scientist for the Curiosity Mars rover. So she's working to develop lots of cutting-edge technology for future space exploration. So thank you so much for joining us. We're super excited to have you, and I'll let you take it away.
Wonderful. Thank you so much for having me. I'm so excited to be here to speak with you all. And I'm going to share a little bit about what I do, what it's like driving rovers on Mars, and how I got to be where I am in the first place. I think how this is going to work is I have a few slides to share with all of you, some pictures, and then I'm looking forward to hearing all of your questions. So I'm going to go ahead and share these pictures that I have. Pop that up. And hopefully you can all see my images now. So yes, I'm going to talk to you all today about what it's like to have a job exploring Mars. So as you guys heard in the introduction, I work at a place called the Jet Propulsion Laboratory, which is part of NASA, and it's located in Pasadena, which is in California, just outside of Los Angeles. Here's a picture of what the Jet Propulsion Laboratory, or as we call it, JPL, looks like. It's a whole bunch of buildings that are kind of nestled in the foothills of the San Gabriel Mountains. JPL is one of many different NASA centers. So when someone says they work for NASA, it means they probably work at one of many different places around the United States. So here is a picture just kind of showing how NASA is distributed across the United States. I'm over here in this area circled in red, the Jet Propulsion Laboratory, and our particular NASA center specializes in robotic exploration. There's some other NASA centers that you've probably heard of, places like the Johnson Space Center in Houston, Texas. They're in charge of the astronauts. So things like Houston, we have a problem, those famous quotes, those are astronauts talking to Johnson Space Center. Kennedy Space Center down in Florida, this is where a lot of the rocket launches go, a lot of the SpaceX launches that go to the International Space Station, where the space shuttle used to launch from. Those are from Kennedy Space Center in Florida. And then, of course, there's NASA headquarters, which is located in Washington, D.C. But as I mentioned, I work at the Jet Propulsion Laboratory, and this is the NASA center that specializes in robotic exploration. I'm interested in all of the planets in the solar system. I think they're all so cool and important and fun to explore, but I think my favorite planet to explore and the one I spend the most time on is Mars, which is also known as the red planet, well, because it looks red. Mars is the fourth planet from the sun, one down from Earth, and it's a really special and exciting place. One of the reasons Mars is so much fun to explore is because it might hold the key to our understanding if we are alone in the universe. Right now, Earth is the only planet that we know has life. Earth is a great place for life. We know the temperature of Earth is really nice. We know there's liquid water on the surface, which is something that life needs. Mars, our next planet over, is not a great place for life. It's really, really cold. It's also really, really dry. There's no liquid water here. But we think one time, a long time ago, maybe 3 billion years ago, Mars had a climate that was a lot similar to Earth's climate today. And we think it was warmer. We think there was liquid water on the surface. And so we wonder, was there perhaps once life on Mars at the period of time when Mars could have supported habitable environments? And so we're going to Mars to explore to see if we can find any evidence that this planet once had life. Now, this is a really interesting, important, profound question, because if we find evidence that there was once life on Mars, that would tell us that the process that formed life, it's not something super special that only happened on Earth. It would tell us that it happened at least twice in our own solar system. And gosh, if it happened twice in our own solar system, it's probably a very prevalent process throughout the universe. I think Mars is also interesting because it has the keys stored in its rock record to help us understand what makes planets have these habitable environments in the first place. So as I said, we think Mars a long time ago was once a lot warmer, once had liquid water, but today it's cold and dry. And so what were the processes that caused the climate of Mars to change so dramatically to make it uninhabitable? Understanding these is a really important question, especially as we start to discover more and more worlds orbiting other stars. If we can understand what makes Earth so nice and habitable in our own solar system and Mars not, it might help us better understand what may make some of these other planets that we're discovering around other stars also habitable or not habitable. And then another really exciting reason to explore Mars, of course, is the idea that hopefully one day in the future, we'll send humans to Mars. It would be a wonderful place to explore, a wonderful place to be able to send astronauts, to be able to look around the surface and study the rocks that are there, to study the planet. And before we can do that, we do need to understand the sorts of hazards that the astronauts might experience. We need to understand the environments on Mars. We need to understand whether or not there are any resources that we can utilize from Mars while we're there to help make living on Mars a little bit easier. And, you know, we hope this will happen sometime pretty soon, and maybe you guys are going to be able to visit Mars sometime in the future. So how do I study Mars? Well, one way that I study Mars is by studying the sites that look like Mars here on Earth. So here's a picture of me in all sorts of interesting places. Most of the places I get to go to look at are very dry. And have rocks that are kind of like Mars. So places like the deserts here in the southwest United States. This picture in the middle here, this is from Iceland, which is actually a really wonderful analogous place to Mars, because the kinds of rocks that you find in Iceland and also places like Hawaii are actually really similar to the kinds of rocks you find on Mars. So actually visiting these places here on Earth that we think are similar to Mars helps us understand the data that we get back from Mars. Another way I study geology on Mars is through these robotic spacecrafts, many of which we build and operate here at the Jet Propulsion Laboratory. Here's a graphic showing just some of the many orbiting spacecraft that we've sent to Mars that are studying the surface from above, taking pictures, collecting information about the composition of Mars, collecting information about things like the remnant magnetic field of Mars. We at this point have so much data about the surface of Mars and the interior of Mars that we've collected from the orbiting satellites. Here's an example of just one of the pictures that we sent back. This picture has a resolution of 25 centimeters per pixel. So something that is 25 or 50 centimeters big, we can resolve it in a single pixel in this image. I love this image because it shows the complexity of the geology of the rocks on Mars. So here we see lots and lots of layered rocks. These were probably put down in watery or volcanic environments. And interspersed between these layered deposits are much more younger wind sand ripples that have been created by the wind. Here's another picture of just beautiful modern day Martian sand that has been sculpted and blown around by the wind. And in addition to this amazing imagery that we can look at from orbit, we can also get information about the composition of Mars's surface. So here is a picture of actually a very special place called Jezero Crater, which I'll talk about a little bit more at the end. So remember Jezero crater. But this is a big impact crater. It's a place on the surface of Mars where an asteroid slammed into the surface and created a big hole. The rim of the crater you can sort of see here, and feeding into this crater is a channel that ends in this beautiful delta deposit. So this is a type of feature that forms when you have a river that's emptying into a lake. And so this shows us that there was probably liquid water at the site. There was probably standing bodies of water at this site in the form of a lake. And the different colors you can see here actually are related to the kinds of minerals that we can tell are present from orbit. And we see minerals that we know form in these kind of environments. We see salts that come out of evaporating waters. We see clays that form when you have waters interacting with the rocks. And so we can integrate the composition with the textures we see from orbit to really start to tell the story of what this area looked like millions and billions of years ago. Another way that I study Mars, and I think this is my favorite way, is by using data from rovers on the surface. So the first Mars rovers that I got involved with were actually the Spirit and Opportunity rovers that landed way back in 2004. So I don't know how old you are, but these may have actually landed before many of you were born. But the Spirit and Opportunity rovers landed on Mars in 2004. They were only supposed to last for 3 months. They were supposed to drive around and look at the geology of the rocks up close, much closer than we can see from orbit. Opportunity actually ended up lasting for almost 15 years. So a pretty excellent rover for something that was only designed to last for 3 months. These rovers were actually what inspired me to go study Mars and become a Martian geologist. And I'll show you why. These were our views of the surface of Mars before Opportunity landed. Here are pictures that are taken from landers like the Viking lander and the Pathfinder rover and even the Spirit lander. And they showed us a surface of Mars that was rusty red and filled with these sharp, dark volcanic rocks. However, the night that Opportunity landed, this was the image that got sent back. This was one of the first images from where Opportunity landed. And this is just such an incredible image. It looks so different from the other images of Mars's surface that we'd seen before. We see this very, very dark sand, and then poking out off in the distance, these light-colored things. This is actually bedrock. This is geologic gold. Bedrock is rock that represents rock that has formed in place. And so it tells you something really significant about the region because you know exactly where it came from and its relationship to each other. And this just looks so different from any of these other scenes that we've seen ever from Mars. And it's just the coolest thing. And here's actually a picture of me seeing these sorts of images come down. I got to actually be at JPL the night that Opportunity landed as part of an outreach program. I was 16 years old, so maybe the same age as some of you. And it just blew me away that you could have a job roving on Mars looking at pictures like this. So I told you I'd mention a little bit about how I got to where I am today. And this is kind of a busy image, but it's a path of my career trajectory plotted against Opportunity's traverse on Mars over 15 years. So again, I was in high school. I was a junior when Opportunity landed in January of 2004. And this is what inspired me to become a rover Martian geologist. And since that time, I went to college. I studied physics and geology in college. After college, I went off to graduate school where I got involved again in the Opportunity rover mission as a graduate student. I defended my PhD in a field called planetary science. Then I moved out to California where I started something called a postdoc, which is kind of a temporary position a lot of people have after they graduate. And eventually I was hired at NASA at JPL where I started as a research scientist, and I've been there ever since, driving these same rovers on Mars that inspired me. So it's been a lot of fun. Opportunity is no longer functioning, but the rover that I spend my most time with now is the Curiosity Mars rover. And this rover landed in 2012. So here's a picture of all of the rovers we've sent to Mars so far, and you can see they look very different. So this little guy down here, this is the first rover that landed on Mars, named Pathfinder. And then getting a little bit bigger, this is what Spirit and Opportunity look like. And this huge, giant rover all the way over here, this is what Curiosity looks like. And so you can see, as we've explored Mars more and more, we've made our rovers much bigger, more complicated, and more capable for doing really awesome science. So this is my field site today. This is where Curiosity landed, in this big hole in the ground that is also an impact crater created when an asteroid slammed into the surface of Mars. This is called Gale crater. And what is so exciting about Gale crater is that in its middle, there's this big mountain of layered rocks. And we saw this from orbit, and we were really excited about it because we realized we could land at the bottom of the mountain and then drive up through the layers, and we would be able to investigate the layers, and they would tell us a story about how Mars's history changed through time. The higher we climbed the mountain, the younger the rocks would be. And we could also see from orbit that these rocks preserve probably big environmental changes that happened on Mars. And we thought they might also preserve evidence of past habitable environments. This is what it looked like when we landed. We couldn't land on the mountain because it wouldn't have been safe, so we had to land on the very flat ground next to the mountain. But man, you can see it rising in the distance, looking just wonderful. And some of the first things we saw right after landing were these neat rocks on the ground that are filled with these big rounded pebbles. And it's really remarkable that these pebbles were rounded. And actually, we realized it looked quite similar to these sorts of rocks that we see here on Earth. And these are rocks that usually form in river deposits when you have water that's strong enough to transport rather large rocks that can roll them around and smooth them and shape them. And so seeing rocks like this told us that there was once a river here running into the crater. This is what the mountain looked like when we spied it through our telephoto camera lens. And you can see there's just layers and layers and layers that we can tell from the distance. And so we were so excited, and we sprinted towards the mountain, and we're now climbing the mountain, studying these layers. When we look at some of these layered rocks up close, this is what they look like. And you can see they're even more finely layered. And a lot of them have these really nice parallel layers. They're very, very fine grained. And so what we realized was that these rocks probably formed in a very calm, very quiet lake that once filled the crater. And so looking at this information tells us that this environment, probably about 3 billion years ago, looked something like this. So rather than a dry, empty crater, we can now say there was probably a river that was running into this area and filled the crater with a lake. And so this tells us that for sure, a long time ago, Mars was very different. And also, we think this lake could have been a really nice place for life to have hung out if there ever was life on Mars. This is what we're looking at today, this morning. This is our current view from Curiosity. We're currently investigating, in particular, this rock right here, which I've drawn a box around. And if you look up close, you can actually see there's 2 little holes in this rock. Curiosity actually made these holes. These aren't gopher holes. These are holes that we made with our drill. We drilled into this rock to collect samples, and we're now analyzing those samples of that powdered rock with the instruments on board the rover. And they're giving us a really detailed look at what this rock is made of and telling us even more about its history. I'll go ahead and wrap up with some even more exciting Mars news. At least this is the NASA news, and that's in back in July, so just a couple months ago, NASA launched our next rover, and this rover is named Perseverance. Here's a picture of engineers building Perseverance that I took at JPL just a few months ago. And here's a picture that I did not take of the launch that happened down in Florida. Perseverance, this next rover, is now on its way to Mars. It's going to be landing in February of 2021. Also reaching Mars in around February in 2021 are a spacecraft from the United Arab Emirates and China. So it's going to be a really exciting time in robotic Mars exploration. And this rover is our biggest, most capable rover yet, and should be sending back some amazing pictures. So stay tuned to learn more about Perseverance in the coming months. I'll go ahead and wrap up and let you know that in terms of Curiosity, you can explore along with us real time. We post mission update blogs that tell what we're doing every day, talk about kind of the newest things we're seeing. Those are posted every time we do make a plan for the rover. So you can find them at this website. And then also every single image that Curiosity takes is posted online real time. So again, you can look at those pictures and you too can follow along with us real time. So I'll leave these up for a second, and then thank you guys all so much for listening, and I'm happy to take any of your questions.
All right, thank you so much for that amazing presentation. I learned quite a bit myself. So we will get Ms. Teeter's class in if you guys have any questions to ask Abigail. Oh, I think you are muted. All right.
I do that all the time. So thank you so much for sharing. That was so amazing. We learned so much, and we are learning about space right now. So it's been perfect to bring this presentation in right now. That worked out so well. I'm just waiting. Oh, okay. Sorry, I'm seeing some of the questions as they're coming in. Did you know Mark Rover?
No, I don't know who that is, but I will say for missions like the Curiosity mission, it takes a team of hundreds and even thousands of engineers and scientists working together to get this very complicated machine sent to Mars. So I know many people on the team, but there are even more people I probably don't know.
Definitely. We have, how long does it take Rover to land on Mars from Earth?
That's a really excellent question. So I think there's two parts to that question. The first part is, how long does it take a rover to get to Mars from Earth? And the answer is it depends when you launch. We usually try to launch our rovers when Mars is as close to Earth as possible, which happens every 2 years. And in fact, so right now, Mars is close to Earth. And just kind of a fun little aside, Mars is actually the closest to Earth like today, as it has been since 2003. So if you all want to go outside tonight, look up at the night sky. You will not miss Mars. Besides the moon, it is the brightest thing in the night sky, really bright, kind of pumpkin colored looking star. You will be able to see it. It looks spectacular. So Mars is really close right now. So we launch our spacecraft now because Mars is close. And in this case, it takes about 6 to 9 months for a spacecraft to get from Earth to Mars. Now, landing on Mars is a different question. We'll define landing basically as the time you hit the top of the Martian atmosphere to when you need to be down on the surface. That takes only about 7 minutes. So a rover has about 7 minutes to go from the something like 13,000 miles per hour it's traveling to get to Mars to completely stopped and landed safely on the surface. So that is a very intense time when all of this is going on. It all has to be done completely automatically. And so we call it the 7 minutes of terror because we're all kind of sitting there terrified it's going to work. But it's also a very exciting time.
All right, awesome. Thank you so much. We will go to Joe and Zeke now and see if they have any questions.
Yeah.
You guys have a question?
Yeah. How long have you been doing your job?
Sorry, can you say that one more time? The internet cut out.
How long have you been doing your job?
How long have I been doing my job? Great question. So I have been at the Jet Propulsion Laboratory for about 5 years now, but I have been studying geology and physics and all sorts of things as a student for many, many years. So I was in graduate school for 5 years, and then I was doing my postgraduate research work for 2 years before I was hired at JPL, where again I've been for about 5 years.
All right, awesome question. We will move on to Mr. LeVogue's class now. Do you have a question? Oh, I think you're muted. One moment.
My fault.
All good.
Get going. I gotta say that Dr. Abby's a personal favorite of our class. I think it's the third time we've chatted with her. We're big space geeks, and we are a couple hours south of Kennedy, and we watched the February launch. We could watch it at the playground at our school.
I'm so jealous.
Yeah,
that must have been amazing.
Yeah, we're big fans of Dr. Abby and Aaron Yazzie are our two favorite JPLers that come on. But one of the questions we have is we talk a lot about creative constraints when we work on projects in our class. You know, all the things we wish we could do if we had the resources and the time and the technology. So my students wanted to know, getting rid of all the creative constraints that would stop you, where would you want to go to explore in space, and why?
Oh, that is an excellent question. Yeah, and you're absolutely right. In reality, there's a lot of constraints that limit where you can go and what you can do. But if there was no constraints, I would love to go to the surface of Venus. I would love to have a rover drive around on the surface of Venus. I think Venus is a fascinating planet, and it's so difficult to study because it's so hot and the atmospheric pressure is so high on the surface that we just don't know that much about it. But I think it is a really interesting counterexample in this question of what makes planets habitable. You know, we have on the one end Mars, which is very cold and dry, Earth, which is just right, and then Venus, one planet over, which is so hot and just crazy. And so understanding why they're all so different is really interesting to me. You also might have heard that there's a recent discovery on Venus. Astronomers detected a gas in Venus's atmosphere called phosphine, which is this really kind of nasty, stinky gas. But one of the ways that phosphine is created is by life. And, you know, looking at the data, we start to wonder, is there perhaps life on Venus, maybe in the clouds of Venus where it's not so horrible? And it could also be that this gas is just created by an atmospheric chemical property that we don't understand. So kind of sending more spacecraft to study that, I think is going to be a really exciting thing that we're going to do, hopefully in the next decade. But I would love a rover on the surface of Venus. I think that would be so cool.
All right, awesome. And do you have any questions for us?
Well, we just joined, but we absolutely are fascinated with astronomy at our school as well. This is San Fernando Institute of Applied Media with my exploration science class. And I have my 8th graders here, and they were wondering, how long has the Curiosity rover been up there on Mars?
Great question. So Curiosity launched in 2011 and landed in August of 2012. So we've been exploring Mars with Curiosity for about 8 years. I'll also say Curiosity, we were kind of warranted for only 2 years. So Curiosity is also another rover that's well past its warranty, but still doing an awesome job exploring. All of the science instruments still work. All of the rover capabilities are still there. So it's still a very productive mission.
All right, awesome. Does Ms. Teeter's class have any other questions? I think you're muted.
Not again. My last question that I see here is, didn't Eli Cologne go to Mars?
Yeah, so I don't know who Eli Cologne is. I'll say at this point, no humans have gone to Mars in real life. There's lots of science fiction out there where humans have gone to Mars, and there's some is better than others. But no, so far, no humans on Mars. But again, this is a long-term goal that I think we have, and hopefully it will happen in the next, 10, 20 years.
Okay. Do Joe and Zeke have any other questions?
Yeah, no. Okay. What was the rocket that Neil Armstrong flew to the moon named?
What was the rocket that Neil Armstrong flew to the moon? That's a good question. So it turns out the rocket that Neil Armstrong and all the astronauts took to the moon back in the 60s and 70s was a really, really big kind of rocket. It was called a Saturn V rocket. For those of you who are near Kennedy Space Center, when you have a chance to go visit, you can actually see a model of this rocket in the visitor center at Kennedy Space Center. And it is huge. It is the biggest rocket that has ever sent humans into space. We don't really build rockets that big anymore right now, but it's quite impressive. Needed a really big rocket to send a lot of mass into space.
Okay. We will see if Mr. LeVogue's class has any other questions.
Yeah, we still do. The students wanted to know what has surprised you most in your field work on Mars?
Oh, that's a good question. I think we've made a lot of surprising discoveries. We found a lot of things that we didn't predict were going to be there from orbit that we only realized when we got to the really fine scale. So I think some of the coolest things that we've seen at the Spirit landing site, what happened was one of the wheels on the rover actually broke. And we had to drag the wheel along. It no longer turned. And when we were dragging the wheel along, it actually churned up a lot of the soil. And we found that just underneath the surface, there was a layer of almost pure silica, which is kind of like beach sand. And we realized that the whole area we were exploring was not a beach, but instead was probably some sort of volcanic hydrothermal fumarolic system. So a system where you had a lot of water kind of moving around that was heated by a volcano. And that was a pretty cool discovery because we never would have found it if we hadn't been dragging the wheel. I think another exciting discovery that we've made with Curiosity, it's not related to the rocks, but actually the atmosphere of Mars. One of the things Curiosity can do is very precisely figure out the kind of gases that are in the atmosphere of Mars. And one of those gases is methane gas. Methane is the same kind of gas that cows make when they fart. And it can form when you have life that produces this gas. You can also make methane when you have water that interacts with rocks. That's one of the byproducts of that chemical reaction. We thought we had detected methane in the Martian atmosphere using telescopes on Earth, and it was quite surprising because we didn't think Mars was active anymore, or certainly, we don't know if Mars has life, but that's an interesting finding. And so we sent Curiosity, and Curiosity's been very closely measuring the methane in Mars's atmosphere, and what we found is there seems to be these seasonal trends of how much methane is in the atmosphere, but we have these occasional spikes where there's this big plume that kind of blows by the rover. And that is so interesting. And we don't actually know how the methane got there or why it's behaving the way it does. And it's been a really exciting discovery. And I think we still have a lot more to learn about that.
All right, awesome. We will take one more question from Ms. Rodriguez's class, and then we will take another round of questions before we wrap up.
Great, thank you. So my students are asking, first of all, why does NASA want to study Mars? And one maybe more relevant quick question, does NASA plan on sending anything to the sun to study the sun? Is that possible?
Yeah, two good questions. So I talked, maybe you came in late. I did talk a little bit about why Mars is so exciting. And I think it's reasons like we want to understand if there was ever life on Mars. We don't know. We think Mars once had the right conditions for life to form. We're interested in understanding, how Mars as a planet works. And then we're also interested in maybe sending humans there sometime in the future. So studying Mars now and the kind of environments that are there is really important before we can think about sending humans there. We want to make sure they're able to live and work on the surface. And the answer is yes, NASA actually has sent missions to the sun. The most recent one was called the Parker Solar Probe, and that's getting really close to the sun, and it's studying how it works as a star. It's a really neat mission that I think has some really special engineering to help it survive the really warm temperatures that it's experienced. It's not in the sun, but it's getting pretty close to the sun.
All right, now we will do one more round of questions before we wrap up. Ms. Teeter's class, I think you had a really good question that you sent to the chat.
For sure. One of my students was wondering, is there a best time tonight to see Mars? When can we see it at its best tonight?
Oh, that's a really good question. I know you can see it after dark, kind of in the early part of the evening, because I went outside yesterday and I saw it. So certainly kind of as soon as it gets dark outside, you can go ahead and take a look, and you should be able to see it.
All right, awesome. I'll have to keep an eye out. Joe and Zeke, do you guys have another question?
Yeah, what planets have you not explored?
Whoa, what planets have I not explored? Well, me personally, several, but in terms of robotic exploration, we've actually sent a spacecraft to every single planet in our solar system, except even including Pluto, which is now a dwarf planet, but I'll count it as a planet for now. So we've sent spacecraft to Mercury through Pluto, and then also several different asteroids in the asteroid belt. There's still a lot more to explore, though. Some of these only just got brief sets of data as spacecraft flew by. So places like Uranus and Neptune, we really only have flybys from the Voyager spacecraft. So one of the missions that we might have in the near future is actually a dedicated mission to study those worlds, because we've never had a mission go there and actually orbit and make really detailed measurements.
All right, that's amazing. So do we have any more questions from Mr. LeVogue's class?
Yeah, the one that's popped up a couple times here is, and I think we could expand it to what you just mentioned about we've sent something everywhere in our solar system, but is finding life during any exploration, like, is that the holy grail, like, of research?
Yeah, I think that is one of the really big driving questions. Obviously, if we were to find life elsewhere in our solar system, it would just completely change the way I think we view ourselves and our place in the universe. I personally think there's also really interesting questions that are related to the life question, but are focused more on, again, understanding how planets work, how they work in the solar system, what governs their climate and their history, and how they evolve and how they form. It's related to life because you need to have a nice environment for life to exist. But I think more broadly, just understanding the processes that are at work in our solar system are really neat questions. So lots of interesting science to do. The life question is pretty high up there, though, in importance, just because I think, solving it would have this huge, profound impact on all of us.
Absolutely. So we will bring in Ms. Rodriguez's class one last time.
Hello again. So we know that Mars is shining so brightly in the sky right now, and my class would like to know, do you have any recommendations of type of telescope? What would be the best way to look at that in the sky?
Oh, good question. So you don't need a telescope to see Mars right now. You can just see it, go outside and look up. It'll look red or pumpkin orange, as I've been saying, no problem. If you do happen to have a telescope, though, and you have the opportunity to look at Mars, you might be able to resolve some of the features. So things like the polar caps on Mars, you might be able to see it through a telescope, depending how big your telescope is as a disk. You might be able to see kind of white bits on the top and the bottom of Mars that are actually the polar caps on the planet. And you might also be able to see kind of dark spots right in the middle. One of these really famous dark spots is called Syrtis Major. This is an area of volcanic lava flows that are just a little bit less dusty, so it looks a little bit darker. These should be visible through a telescope, probably like a 3 or a 4 inch telescope, something like a 6 or an 8 inch telescope. You'd definitely be able to see these features. But again, even just your naked eye or a pair of binoculars, it should still look pretty spectacular. And, I'll also say, I talk about my experience seeing Opportunity landing as being really inspiring. Something else that really inspired me to study space was seeing Saturn through a telescope for the first time. And it was just this little tiny baby telescope that I had sitting on the front steps of my porch. But the notion that you can see kind of light coming directly from the planet to you, not through a photograph, not through a spacecraft, but directly from the planet to you is the coolest thing. So if you do have the opportunity to see Mars through a telescope, especially right now, absolutely take that opportunity, because I think it is so cool.
Definitely. I think we have one more person joining us, Akash from India. If you have any questions,
Hello.
Hi there. Do you have any questions?
There were some network issues, so I was not able to join it. Okay, I'll ask my question. My question is, what are the similarities in geographical history of Mars and the Earth?
That's a good question. What are the similarities in the geological history between Mars and Earth? And we actually think there's quite a few similarities, especially 3 or 3.5 billion years ago. We think the kind of processes that were operating on Mars and the climate was very similar to Earth. A lot of the processes like volcanism, the creation of what we call sedimentary rocks that form in kind of either wet or windy environments. We find all of that in the ancient Mars's rock record. And in fact, if you look at 3.5 billion year old rocks on Earth, there's a big similarity between them and the 3.5 billion year old rocks on Mars. At some point, though, the histories did diverge a lot. It might be related to when Mars lost its magnetic field. Mars used to have a magnetic field. It doesn't anymore. With the loss of the magnetic field, we think the atmosphere of Mars got a lot thinner. We think the climate got a lot colder. Everything kind of slowed down. The volcanoes stopped going off. And so at that point, I think the planets did diverge. But certainly 3.5 billion years ago, Mars and Earth probably looked like very similar places.
All right. Thank you so much, Abigail, for joining us today. It was absolutely amazing hearing all of the cool work that you've done. And it sounds like there's quite a bit still to be discovered about Mars. So maybe that's something that some of our students joining us might like to explore in their future.
Wonderful. Thank you so much for having me again. I love speaking with you all so much. And, I love talking about Mars and space exploration.
And we loved having you. Thank you so much.
Great. Thank you. Bye, everybody.
Bye.